जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मागे। गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
रसिक हो नमस्कार. सहर्ष सादर करीत आहोत ज्ञानसाधना गीत. कवी प्राध्यापक प्रवीण दवणे, संगीत विनय राजवाडे.
शिवाचे मंदिर सुंदर मानव्याचा ध्यास निरंतर. सत्य शिवाचे मंदिर सुंदर मानव्याचा ध्यास निरंतर. गुरु शिष्याच्या नात्यामधली प्रतस्थ मन साधना. सदैव उजळो आपुली ज्ञान साधना ज्ञान साधना. स्वर येई उजळून शूरवीर संतांचे पूजन जागविते चेतना ज्ञान ज्योतीने
A very good evening to one and all. On a good day like this, it feels a bit sad to stay inside and not get together to celebrate like we all usually do. But this is the time to be patient and united in our efforts to stay inside and instead find more creative ways to keep learning and entertaining. Myself, Miss Parab, the proud student of Satish Pradhan Dnyanasadhana College, Thane. On this occasion, I would like to happily welcome you all and thank you for joining us on 11th program of Glorious 40 organized by the Department of CSIT, and the topic for today being driving force behind the demand for data science. As we all know that the college is celebrating 40 glorious years of being in education and modernity. In views of 40 years, we are presenting 40 unique programs. So, as we begin, I now would like to request the leader of our army, that is our principal, Dr. Chandrasekhar Marathe sir, to share few words. Over to you, sir.
Good evening. Welcome to this program number 11 out of 40 programs that we are going to celebrate on completion of 40 years to our institute. We completed 40 years on 29th of August 2020, and since then we have been arranging various programs, and today is the 11th program, driving force behind the demand for the data science. And I am happy to see a student of mine who is going to give you information on this driving force behind demand for data science. I welcome Sampada Basarkar, and her husband and herself both are the student of mine. It's very nice to see a student delivering a talk on the occasion of celebration of 40th year of our institution. I welcome Sampada once again, and with these words, I hand over the mic to the organizers, and then eager to hear from Sampada. Thank you.
I would like to express my sincere thanks to Dr. Chandrasekhar Marathe sir, principal of Satish Pradhan Dnyanasadhana College, for his wonderful sayings and for always being an inspiration and pillar of strength behind us. To teach is to learn twice over. Better than 1,000 days of diligent study is one day with a great teacher. With this, I would like to introduce Dr. Vidya Lonkar ma'am. She was the ex-vice principal of Satish Pradhan Dnyanasadhana Junior College from 2015 to 2017. She was Commerce Department faculty and serviced in our college from 1981 to 2017. It was my honor to introduce Dr. Vidya Lonkar ma'am. I now would like to request Dr. Lonkar ma'am to take over. Over to you, ma'am. Thank you.
Hearty congratulations to Satish Pradhan Dnyanasadhana College for completing 40 years very successfully. I am very happy and delighted to mention that my association with Dnyanasadhana College began back in 1981, an association of 39 long and happening years. Many institutions may complete even 50, 60 or even more years, but for Jnanasadhana, the journey of 40 years is unique. As unlike others, it believed in giving admissions to the students on first come first served basis, irrespective of their percentage of marks. Thus, college opened for them the doors of higher education. This also gave the teachers a golden opportunity to mold their teaching techniques accordingly to meet the challenges. It has been effective, has very often been proved, as many of our students are very successful and doing well in practical life. As a teacher, I would like to mention my experience, which I think is unprecedented. Our first principal, late Sri Shyam Phadke sir, would always encourage us to talk to our students on different topics other than our subject of teaching, either on current affairs or some topics which will boost up their morale. Thus, even when moral science was not a part of syllabus, we had it in our day-to-day teaching. He also arranged various programs and encouraged our students to take part in various competition and speak on various topics. He believed that through this, the students who lack interest in studies because of their low merit will be encouraged to come to college, attend the lectures and will progress. I must say that this experiment was proved to be a great success in initial years. These programs and communication with our students also helped us in developing a good emotional bond with them. This bond is long lasting. At the inception of college, with some 200 plus students to now 9,500 plus students, Dnyanasadhana College has progressed a lot. But this is not only a quantitative progress. With the normal graduation and post-graduation in arts, commerce and science, college has offered numerous other courses to cope up with fast-changing educational trends and even PhD research facilities. Not only curricular, but co-curricular and extracurricular activities are also given due importance in college. Facilities of special coaching in various sports, well-equipped gym, language lab are among the few to mention. Our NSS and NCC civil defense units have also done a remarkable work over the years. Working through these units, the students have learned the life skills such as cooperation, leadership, which enable the students to stand firm in difficult situations. Even during the present corona pandemic, some of our students are relentlessly helping the senior citizens in Thane. From 1980 to now, the college has grown from 9 teachers to 200 plus teachers and more than 200 plus office staff. The management under the able leadership of respected Sri Satish Pradhan sir has maintained a very cordial and healthy relation with all, which make us say that it is a Dnyanasadhana Parivar. Even in difficult times, when college was not on government aid, Parivar members never faced any financial difficulty because of wholehearted support of management. At Dnyanasadhana College, the teachers are always encouraged to use their creativity in curricular, co-curricular or extracurricular activities. The management as well as all the principals, right from late Sri Dalvi sir, Dr. Vishay sir and current principal Dr. Marathe sir, all the principal, our secretary Kamlesh Pradhan as well as colleagues are always there to cooperate with Parivar members. Even in my social endeavor wings, college has supported me a lot. For any teacher, two things are important. First, the respect and recognition from management and second, acknowledgement from our students. I am very grateful to Dnyanasadhana College for giving me both. That is why even after retirement, we feel that we are still a part of college. And when I meet some students on the streets of Thane telling me how she remembered me on the very first day of job as an accountant, I feel a sense of fulfillment. What else any teacher would wish for? Thank you, Dnyanasadhana. You are and will remain a very important part of my life. Thank you.
I would like to express my deep gratitude to Dr. Vidya Lonkar ma'am for gracing today's session by her very thought-provoking and motivational address. So, without any further ado, I now would like to request Mrs. Shilpa ma'am to introduce today's guest speaker. Over to you, ma'am.
Good evening, everyone. I'm Assistant Professor Shilpa Hatewar, and it's my pleasure and privilege to welcome you all on behalf of Computer Science and Information Technology Department of Satish Pradhan Dnyanasadhana College. I wish to welcome our guest of honor, Ms. Sampada Basarkar ma'am, all my colleagues and all the students. I extend a warm welcome to all at the program number 11 under the umbrella of celebration of 40th glorious years of Satish Pradhan Dnyanasadhana College. I find immense pleasure in introducing our honorable chief guest, Ms. Sampada Basarkar ma'am. Ms. Sampada is Senior Director of Engineering at IBM Analytics, San Jose, California. San Jose is noticeable as a center of innovation, and due to booming high-tech industry, the city has earned a nickname of Capital of Silicon Valley. Ms. Sampada is having a work experience of more than 22 years. She had developed a strategy at IBM for several data and artificial intelligence offerings, leading high-performing product development and delivery with global terms in India, Canada, Israel, and US. She had worked with more than 500 key IBM enterprise clients, and also she is a key member of team that designed the data and artificial intelligence platform. She has represented IBM through speeches and presentation at various industry events such as Spark, Hadoop, and Artificial Intelligence Summit worldwide, and served as a moderator at various Gartner CIO events on data and artificial intelligence. It gives me a great pleasure to say how grateful we are to Ms. Sampada Basarkar ma'am, who has accepted our invitation to convene the webinar on driving force behind the demand for data science. It is gratifying to note that the agenda of webinar covers a wide range of interesting information about data science. We are privileged to have an attendance of such an expert resource person. I am truly fully confident that expertise of Ms. Sampada Basarkar ma'am will provide an important insight on data science. So I invite Ms. Sampada ma'am to take charge. She will be joining live with us from San Jose, and it is approximate 4:45 a.m. morning over there. Over to you, Sampada ma'am.
Hello everyone. Thank you Shilpa ma'am for warm welcome. Thank you to Marathi sir and Sarika ma'am for inviting me to Satish Pradhan Dnyanasadhana College and giving me this opportunity to talk about the emerging field of data science and AI. Can everyone see my screen? Or everyone see the slides? All right, let's go to the next slide. I'll start again. All right, everyone. Thank you, Shilpa ma'am, for warm welcome, and thank you to Marathi sir and Sarika ma'am for inviting me to Satish Pradhan Dnyanasadhana College and giving me this opportunity to talk to you about the emerging field of data science and AI. Let's move on to the next one. I want to just start with what is the difference between data science, ML, AI. You probably have heard these terms. You probably have heard terms like deep learning, big data. So I just want to start off with what are these terms? What do they mean? What is the context of data science when we talk about AI? So AI is really a wide term. Machine learning, data science, deep learning are all subsets of artificial intelligence. There's no single definition for AI. You can think of AI as the ability that we can impart on machines to understand and interpret data and learn from data to make intelligent decisions. And these decisions are based on the insights and patterns that are drawn from data. Data science and big data are now becoming almost inseparable. Without big data or without data, there's no data science. Whereas deep learning allows machines to solve complex problems when using data sets that are very diverse. When you have unstructured data or interconnected data, that's when you really use deep learning. And deep learning is also a powerful set of technique used in neural networks. Next one. So today we're going to cover 4 topics. We'll talk about what is data science. We'll talk about the data science process. We'll talk about what are some of the common use cases and algorithms used in data science. And we'll talk about the opportunities that exist within the data science field. Next one. The question is, how old is data science? The word data science itself was coined only in 2008. However, the technique of uncovering insights and trends from the data have been done for centuries. Even the ancient Egyptians used census data to increase the efficacy or efficiency in tax collection, and they accurately predicted the flooding of Nile River every year. But only recently have we formalized the gathering, the organizing, the collection, and analyzing of the data into its own unique field of technology, which we call as data science. And this is possible only because of the advent of computing, cloud storage, and high power computing. Next slide. So data is growing exponentially. In fact, over 2.5 exabyte of data is created daily. The number of embedded devices are growing. Embedded devices such as found in smart devices, manufacturing floors, driverless cars are growing really fast. Data from new sources such as social media is growing at an increasing pace. Many companies have centered their businesses just around data. In fact, the massive growth of data has opened up new risks to private and sensitive information. The rate at which the decisions are being made these days is growing significantly, and we're moving towards a digital economy, and data is becoming a lifeblood of digital economy. As the data grows, the transactions related to the data also grow. There will be seemingly massive problems related to data, and they can only be solved by data science techniques. Next slide. Now let's look at some of the examples. We'll go through a few industries. We'll look at banking, manufacturing, healthcare, e-commerce, aviation industry, and we'll look at some of the examples of where data science is used in each of these industries. In banking or finance, the most common type of application of data science is fraud detection. And scenarios are sort of payment fraud. One of the scenarios is payment fraud. Data science will help determine which transactions are most likely to be fraudulent while significantly reducing the false positives that the bank may have to deal with. In manufacturing industry or manufacturing floor, one of the biggest challenge is to minimize the downtime, especially unscheduled downtime. And this causes loss of efficiency in the manufacturing floor. And this is where data science can help us predict machine operation efficiency by increasing the manufacturing efficiency. In healthcare industry, you have X-rays, CAT scans, MRI. There's a lot of data generated from these devices. And this data can be used for diagnosis, prevention, preventive measures. I don't know if you've heard of IBM Watson Health. IBM has a separate division specifically to deal with the healthcare industry. In e-commerce, the retail giants like Amazon use data science extensively, and they use this for making personalized product recommendations or determining customer behavior or shopping patterns. Next one. Let's look at some more examples. Automobile industry. Many auto companies are manufacturing autonomous cars or self-driving cars. In fact, the prediction is by 2025, majority of the car manufacturing companies will produce autonomous cars. Now let's think about the decisions that the autonomous cars or the self-driving cars need to make. And seemingly these decisions, they have to make them at 100 kilometers per hour as they're driving at 100 kilometers per hour. So some of the things that the cars have to analyze are pedestrians walking on the road. They have to analyze proximity of another car. They have to analyze speed limit considerations, navigation, changing lanes. All of these things have to be done by the car, and the car has to analyze enormous amount of data in real time. Autonomous cars use techniques like computer vision, ML on edge. Without data science and associated algorithms, this would be an impossible task. Similarly, in manufacturing, we have, as I mentioned earlier, predictive maintenance is a huge issue in manufacturing. So manufacturing, automation, predictive maintenance are some of the areas where data science is used. Next one. Let's look at the airline industry. In airline industry, while predictive maintenance could be a very common use case in airline industry, the other use case that I can think of is real-time passenger itinerary changes due to delays or missed flights. In fact, 30% of the delays of the flights are caused due to unpredicted weathers. And this is a huge overhead for the airline industry because they have to rebook the passengers. And airline industry is solving some of these problems using data science. Some of the other examples are promotional planning. Let's say if you go from source to destination and you've landed at the destination, giving you promotions of where are some of the good restaurants that you can go and eat in your destination city. Predicting delays is another area where airline industry is using data science. Next one. So what is data science? Data science, as the name suggests, is really about data. It is a multidisciplinary field. It's focused on drawing insights that can help organizations make better decisions. It's a blend of tools, algorithms, machine learning principles. It helps organizations discover hidden patterns from the raw data. And such data-driven decisions can be extremely valuable to improve efficiency of the organization. It helps them reduce cost. It helps them increase productivity. And it helps them, more importantly, increase revenue. Next one. Now let's look at what is the value of data science. Data science helps companies understand their clients more. It helps clients make sense of their data. It helps companies draw insights from the data, drive business value and grow business. So essentially, data science enables business to make better decisions with quantifiable evidence. It helps improving the relevancy of their products. It helps clients make sense of the massive data that they're collecting. It helps them uncover new insights and helps them also drive new business value and growth. Next. Let's look at the data science life cycle, and let's look at what are some of the steps that are necessary in the data science life cycle. This is also called as an AI ladder. There are steps that every data scientist needs to take in order to complete the data science projects. These are the steps every organization takes to as they embark on their data science journey. So the first and foremost is to formulate the question or the problem. The understanding, defining goals, organizing resources around those goals, coordinating people, scheduling the project, understanding what exactly you're trying to solve is something that's done as part of the formulation. The next one is really acquiring and cleaning data set. The third one is exploratory analysis. The fourth step is drawing conclusions using predictions, inferences. The fifth step is deploying models, training the models, deploying models. And finally, the next step is revisiting models. This is also a very important step because once you've deployed the models, you cannot just that it doesn't end over there. You have to constantly go and revisit the models. You have to constantly go and retrain the models. And we'll go through each one of these steps in a more detailed manner. Next one. Now let's look at this area, which is formulating question or the problem, understanding the decisions to be made, determining what data is needed to make the decisions. So every use case at a company starts with a question or a problem. Understanding the goal of the data science project is super critical. What type of decisions are to be made? Do we have the right process for making those decisions? So data scientists try and ask a lot of questions to figure out what is the problem that the organization is trying to solve. They also try to determine what is the right architecture that is needed to support the decisions. They try to determine whether they have the data needed to make those decisions. So formulating the question or the problem, understanding the business problem that the business is trying to solve is super critical. It starts with that, it's super critical. Next one. The next step is really about collecting the data. This is the collect phase. And this is the phase where data scientists acquires the data. This is the phase where they try to get the right data for the data science project. Let's take an example. Let's say you're trying to build a recommendation engine or a recommendation system. In order to build a recommendation system, you may need things like demographics data. You may need things like customer transaction. Without this information, how will you even recommend clients what are some of the new products that can be associated or they can buy with the product that they're trying to buy right now? Think about the fact that transaction data may be available in a completely different data system, whereas your customer data might be available in a completely different system. Let's say your customer data is available in your CRM systems. In fact, in large organizations, there are tens of thousands of such sources. So data scientists have to work with data engineers, data stewards. These are some of the personas that I'll talk about a little later. But the data scientists have to work with these different personas in the organization to get access to the data. Sometimes they have to run ETL jobs. ETL jobs are jobs that are run to extract the data from the source, transform the data in some manner, load it in the target system. They have to run these ETL jobs. Sometimes they may have to refine the data, wrangle the data, cleanse the data, because the data that they may have got may not be in the right shape, format. So many a times, data scientists have to spend a lot of time cleaning the data, because if you don't have clean data, your results for when you start training the models may not be relevant. So, and data scientists use variety of techniques such as data refining, data cleansing, as sort of the second step. Once they've understood what problem they're trying to solve, and they start to acquire data and clean the data, they use variety of techniques for refining and cleaning. Next one. The third step in the data science lifecycle is really exploratory analysis. This is a very important step because this is a step where the data scientist tries to make sense of data. They try to understand the data, context behind the data. The data scientist cleans the data to ensure it's free from errors. Because as I said earlier, garbage in and garbage out. If you have garbage data, and trust me, organizations do have a lot of garbage data. So if they get this data which is not clean, which does not give them the right results for their model, they will not get the right accuracy for those models. The accuracy of those models will be impacted. And as a result, if the accuracy is impacted, the models cannot be trusted. Hence, the data scientists spend enormous amount of time trying to do a lot of data cleansing and exploratory analysis. In fact, I think some of the businesses that I've talked to have said that 70% of the data scientists' time is actually spent in collecting and organizing and cleaning the data. Next one. So once the data is cleansed, once the data scientists have figured out that there is no bias in the data, once they've found out that the data is seemingly accurate, then the next step starts, which is the fourth step, which is the model deployment phase. And in this step, the data scientists will build models based on the data that they have. The data scientists will validate the models against the data they've collected. They'll also use various visualization tools to present the data. They'll perform the necessary algorithms, statistical analysis. They'll look at accuracy and efficacy of the model. They'll compare the results against other techniques and sources. So this is the phase where the model training starts. Sometimes new machine learning algorithms have to be built. This is the phase where the data scientists will build those machine learning models. Sometimes they might use existing machine learning models, machine learning techniques. So this is the step where the model development and the model selection starts. Next one. And finally, then the fifth step is model deployment. This is the step where the models are promoted to the production systems. But before the models are promoted to the production system, the data scientists also have to do several other things. They have to generate documentation about this particular model. They have to make sure that that the models that they've created are using the right execution environments. And these execution environments could be Spark, TensorFlow, PyTorch, H2O. They also have to make sure that the models are integrated with the production systems properly. This is the step where they determine the execution environments. This is the time where the input is really the data that you have, the models that you've created, can take in an input and return the output, and this is the step where the models are used in the practical business decisions. Next one. Let's talk about what are some of the operations in data science. So the first operation, that there are many operations that can take place in the data science field. And I'll talk about few operations here. The first one is descriptive analysis. Descriptive analysis is done if a business is trying to understand what happened in the past. In this case, big data can be used, and it can be condensed into smaller and more useful chunks of information. This is um, this is an analysis that is used to understand a percentage change or an aggregate. What happened in the past. So that's what descriptive analysis is used for. A predictive analysis is done to predict what is most likely to happen, or what is most likely to happen in the future. One of the examples of predictive analysis is sentiment analysis. Prescriptive analysis is a type of a predictive analysis, but it's associated with an action for a user. For example, a recommendation system is could be predictive and prescriptive, because recommendation system is giving recommendations, trying to sort of gauge interest from the buyer by giving recommendations. At the same time, an action could be a user actually buying that particular product. Now let's take a look at some more examples. Classification is yet another operation in data science which is used quite extensively. And classification splits objects based on the attributes known beforehand. One of the examples of classification is spam filtering. You've used your emails, Gmails, Yahoo Mail. How does the mailing system know that a particular mail that you've got is spam and automatically filters that out, right? So they use these classification algorithms as part of this process. Some of the algorithms that are used in classification analysis are decision trees, logistic regressions. These are some of the algorithms that are being used. Another example of classification is separating music by genre. That could be a classification example. Dimensionality reduction is another type of analysis that is being done. And here you assemble specific features into a more high-level ones. And this can be used for risk management, visualization, etc. So because I mentioned this term feature, let me also very quickly explain what are features, because this is something that you will hear in data science field quite often. Features are really parameters or variables. These are the parameters and variables that exist within your data. Let's say you have car data. Car mileage could be one of the feature. Let's say you have customer data. Customer user's gender could be one of the feature. Stock price could be a feature. So in other words, features are factors for machine to take a look at, and feature play an important role, because these are the ones that are used in operations and analysis. All right, next one. So we went through the 5 steps. The first step was understanding the problem. The second step was collecting the data. The third step was sort of exploratory analysis. The fourth step was exploratory analysis and sort of model training and testing. The fourth step was deployment of the models in production. And then the final step really is once the models have deployed, once you've done the analysis, the final step, which is a most critical step in the organizations, is sort of revisiting the models periodically. And the reason this is a critical step is because most organizations, they have expiration dates on the models. And the reason they have expiration dates on the models is because the data changes over time. And as a result, the model output may not be consistent. It will vary. If the data changes over time, the model output will also vary. There's degradation in the model. And there's once you start having degradation in the model score, it's called drift. It means that the model is drifting. And this happens due to changes in the environment. It can happen because of the changes in the relationship between the variables that are being used in the organization. It could happen because of the changes in the data that happens on a regular basis in organizations. So a gradual change over time can suddenly make change, suddenly start to have models to drift. I can give a couple of examples. So let's take a look at a recent example. Let's say you're buying something from Amazon.com. Let's say your models are trained, using recommendation engine to, if somebody buys, let's say, a Vicks VapoRub, that they are recommended thermometer. Okay, and then the user, as I said earlier, through the prescriptive analysis, users can click on that thermometer. Okay, but now because of COVID, let's say the trend is changing, where customers are buying masks instead of thermometers. Now, what will happen is the model is trained in a way where if users are buying X, then the users are also buying X, Y, and Z with X. But the value, the Y now has changed. And as a result, the model accuracy will start going down. And this, as I said earlier, is called drift. And in such situations, the data scientists will need to go and revisit the models. They'll have to go and update the models. They'll have to go and retrain the models. And this is a super important step in an organization to ensure that the accuracy of the models continue to remain high, that the models are trustworthy. Next one. Let's take a look at some of the job functions in data science. I mentioned earlier about data engineers. I mentioned a little bit about, I didn't probably mention about business analysts, but let's talk about some of the job functions that I've seen within organizations that I've been closely associated with, specifically related to the data science field. So there are three job functions. We have the data engineers, we have the data scientists, and we have the business analyst. Sometimes the data scientist can wear multiple hats and they can do all the three job functions together. In some organizations, especially large organizations, data engineers, data scientists, and business analysts could be completely separate job roles. Data engineers are the ones who are helping collect the data, organize the data. They are the ones that run SQL queries. They are the ones that manage big data platforms like Hadoop. They are the ones that run SQL commands or manipulate data through HiveQL. These are the personas. Data engineers are the personas that take care of the database systems. Data scientists are personas. They build models, they train the models, they use different development environments like Jupyter, Anaconda to build models and train models. And then business analysts are the ones that generate reports. They try to understand the business impact. So in some companies I've seen there are three different job functions specifically around this. In some companies, these three job functions are sort of fused together and the data scientists end up doing all the three job functions. Next one. So now let's take a look at some of the fundamental skills that are required for data scientists. In order to become a data scientist, there are few things that are critical. Number one, you need to know programming. You need to at least know Python and R programming. If you're trying to do more statistical algorithms, then maybe R programming is necessary. Otherwise, Python is widely used. Understanding of relational and non-relational databases is extremely critical. As I said earlier in my previous slide, the data scientists have to do a lot of data cleansing, lot of data munging. In order for them to do that, it's very critical that they have an understanding of relational and non-relational databases. Understanding of distributed file systems like Hadoop, Spark is also critical. Sometimes in order to run your models, you might have to use Spark execution engines. Understanding of commonly known machine learning algorithms is also super critical. And of course, math is a very fundamental skill for data scientists. Next one. Let's take a look at some of the commonly used ML libraries in the data science field. These are all machine learning libraries available through Python. PyTorch is a deep learning library, and PyTorch was built by Facebook. As its name implies, PyTorch was written in Python. TensorFlow is another library. It is a symbolic math library. It's used for machine learning applications such as neural networks. Pandas is very commonly used for data manipulation. It's used for creating data frames. So you can Google a lot of these machine learning libraries. You can get details around what these machine learning libraries do. Next one. So some of the math that is used in data science is sort of good foundation and understanding of linear algebra, statistics, calculus, Bayes theorem. These are commonly used things in data science. Linear algebra and stats are commonly used. Linear algebra is in fact used in image recognition, text analysis, as well as dimensionality reduction. And calculus is used in sort of optimization techniques. Calculus is also used to carry out mathematical modeling of neural networks. So as you know, as you can see, mathematics is a very important part of data science. So just to recap, next slide. So just to recap what we've talked about, from the first or the second slide to now, so we've talked about why data science is gaining popularity. The reason data science is gaining popularity is data is growing massively. The only way organizations will be able to make sense of the data that is growing massively right now is through the techniques used in data science. We've talked about some of the common use cases in data science. We've looked at how different industries are using data science to increase the value of their organization. We've talked about what is the data science process. We went through the process of collecting the data, organizing the data, analyzing the data, deploying the machine learning models. We've talked about revisiting the models. So that's data science process we talked about. Then we talked about the job functions in the data science. We looked at who are the data engineers, who are data scientists, what are their job functions, what do they do, business analysts. We've looked at how sometimes these job functions are fused together. A single person can do all the three jobs in large organizations. It could be separate jobs. And we also looked at the skills required to be data scientist. So that's all I had today.
Thank you, Sampada ma'am, for your eloquent speech. This was very enlightening to me, and I'm sure everyone would resonate on this. Now we move towards our next session, that is question and answer session, where I would pose questions, doubts, and queries which are shared by our students. I believe this would be repetitive for a person of your stature, but a little bit more explanation and knowledge sharing will go a long way with the students. We are receiving many queries and doubts from the student side, but due to the limitation of time, I'm selecting a few one. The first question, which is coming from Sahil Khilje, and he is asking, does a data scientist needs to be better at statistics or on software engineering skills? A very thoughtful question, ma'am.
It is indeed a very thoughtful question. Yeah. So my take here is, in general, it's both. And I think the ratio of whether you need more programming skills or more statistics skills really depends on what kind of problem you're trying to solve. Sometimes, depending on, let's say, if you're trying to solve something that's more math related, then you might need more statistical skills. But besides these, I would say the data scientist also needs skills like critical thinking, knowledge on sort of the data architecture, as I mentioned earlier, um, uh, understanding of these days, you get a lot of pre-built services and offerings. So understanding of those pre-built services and offerings, and sort of the ML related, general ML related domain, is super critical. So I would say depending on what use case it is, the skills may vary. Sometimes it could be more statistical skills, and sometimes it could be more programming skills.
Okay. Thank you, ma'am. Now, the next question, which is coming from Priyanka Dhurat, and she is asking that the present and future age deals and demands big data. Do you think there is any curse of big data? Again, one more
I think
interesting
big
question.
data is absolutely interesting. Big data itself is a big curse, I think, because big data really brings in challenges that are related to volume, the variety, the veracity of the data. And if we talk about pattern recognition from this big data, if we talk about labeling of the big data, it's a massive problem. Many companies actually have just businesses dedicated, towards labeling of big data, and tagging videos, tagging images, uh, the when you start doing use cases, such as image recognition or computer vision. How would a computer know what is the difference between a cat and a dog by just looking at images, right? So you have to train the algorithms with thousands and thousands and thousands of images for it to make those right decisions. And as a result, because the data is growing, because the data is increasing, the overall challenges that we have to deal with related to data have just been massively growing. As I said earlier, right, the big data and data science are sort of, they are fused together. You cannot separate them these days. And in order to really solve these big data challenges that we have, uh, you really need data science. The data is getting generated at a massive scale these days, and it's humanly impossible. We used to have statisticians in the past who would analyze the data, but now it's humanly impossible to analyze the data that is growing this massively. So I truly believe that it's a curse in a sense, that is just growing too rapidly. uh, but the good thing is there are techniques now that can be used to make sense of that data. uh, Finally, in the end, after the data is collected, you really want to make sense of the data, and that's what data science is really used for.
Thanks, ma'am, for the details you shared with us. Now, the next question, which is framed by Lakshman Dangwe, and he's asking, with your expertise in your domain, what would be your opinion on qualities, qualifications, skills, etc., needed for a good data scientist?
So, in terms of the qualifications, I covered some of those aspects. I mentioned that we need programming skills. Python and R are super critical. I mentioned we need the data structure skills, understanding of the databases. I talked about some of the Hadoop skills that are required, especially Spark, because you might be using Spark execution engines for running your ML algorithms. Um, Having some industry knowledge is super critical also, because you might see you might see some of the use cases which are very industry specific, and having some industry knowledge is super critical. I would also add one more over there, and that's critical thinking, collaboration. So I think it's really there are soft skills needed, which is critical thinking, collaboration, and then there are technical skills needed, which is really understanding of data structures, programming, execution engines. So I would say that would really make a good data scientist. Really, a combination of all these things would really make a good data scientist.
Thank you, ma'am, for your elaborate answer. Definitely, I'm sure all the students will definitely get benefit out of this. Now, the next question here comes, which is posed by Mr. Sahil Gupta, and he is asking, how do we use social media to predict weather forecast? How do we collect, collate, and analyze the forecasting data?
So, in order to forecast weather conditions, or in order to forecast sort of predict the weather conditions, meteorologists, use first they try to understand what is the current weather condition. They try to understand what is producing the current weather patterns, right? So that's what they try to understand. And this is done by seemingly sort of large quantity of observation data that they gather from satellite imagery. They get data from radars, they get data from wind profilers, they get data from river gauge. So they do river gauges. So they get data from a variety of different sources, and that's how they try to predict what are going to be the weather patterns. Now, social media, I would say, is really useful in providing giving quick information on what is going to be a weather pattern in a particular area. So I think that would be one aspect of how social media can be used with weather forecasting. But in regards to the prediction, how can social media be used to predict the weather conditions? I would say if the meteorologists are trying to look at certain regions, and now let's say they want to look at other regions, for weather conditions and weather patterns, they can get that data through social media far quickly, sort of seemingly pretty fast, and the speed, I would say, would definitely affect the accuracy of their predictions, and they can also, let's say if there is a weather pattern changing in a certain area and they see that through social media, they can very quickly look at the satellite imagery in that area and see what is happening, right? So as a result of that, they might be able to predict the data predict the weather patterns and the weather conditions much faster.
Thank you, ma'am. Every day we are seeing the weather gets changed. One day it's
I
sunny,
know.
other day it's raining. So actually, it was a very practical question posed by Sahil Gupta.
Yeah.
So over to now the next question, ma'am. As you must be aware that all the students, most of the students who are attending this webinar belongs to computer science and information technology stream, and they are learning R, Python, and other programming language as a part of their curriculum. So the next question is actually related to programming language, and the question posed by Vikrant Singh. He is asking, among analytical languages like R and Python, which should be studied and mastered for the future? Again, very futuristic question. Very interesting.
It is. It's a super interesting question. So I'll give you my perspective. And again, as I said earlier, it depends on the use cases that data scientist is trying to solve, right? So Python is a most widely used programming language right now. There is a lot of support on the web that you can get for Python if you're trying to create your models, or you're trying to train your models. Python has a set of libraries that you can use. Python has pandas library. I talked about all the libraries that Python language has, machine learning libraries that Python has. So it's a much easy language to use, and it's a language that is used by majority of the data scientists. R is more suitable for sort of machine learning especially if you're trying to do statistical analysis. If in my experience, the engineers that I've worked with, they often use Python for text analytics. So I would say if you have to sort of prioritize the programming languages that you're trying to learn, and you're looking at 2 years or 3 years ahead, I would say definitely start with Python. Gaining a deep understanding of Python is super critical. I would say if you're inclined towards more statistical sort of, if that's your inclination, statistical programming, statistical analysis, then I would say do R. In the past, there were more R programmers. In the recent times, in the last 5 years, there are more Python programmers. So 5 years prior to that, I would say R was the most prevalent language that was being used. But in the recent times, and I would say even in the next few years to come, Python will be a very important language. The other programming languages that I can think of are also like Go. Go is also gaining a lot of popularity. So if you haven't heard about Go, I would say look up. Scala is also another programming language used. If you are trying to do sort of large scale ML operations, then Scala is also another programming language that can be used. But I would say start with Python. Python is used mostly for, it can be used for text analytics, recommendation engines. It's a very widely known, popular programming language. It has a lot of built-in support for ML algorithms. So I would definitely start with Python.
Thank you, Sampada ma'am. So Vikrant, go for Python and Go language. Now the next question, which is related to statistics, and I'm very happy because I'm a statistician. So this question is posed by Ms. Siddhi Pokre, and she is asking, explain the importance and use of statistics for being a data scientist.
So statisticians, are really use statistical, and you most likely you will know it also because you are a statistician. Statisticians use sort of the statistical formulas and computer algorithms to understand the patterns and trends within the data. And data scientists can also apply these statistical concepts for probability, for distribution, for sampling, dimensionality reduction, and they can use these statistical concepts to sort of make conclusions from the data, to draw conclusions from the data. So I would say statistics is used by data scientists if you're trying to do more statistical programs, and if you're trying to build your use cases around sampling, dimensionality reduction. So that's where statistics is widely used.
Thank you, ma'am. Now we have reached to the last session of our program. The last question is coming from the last question is coming from Priyanka Jaiswar, and she's asking, what are the best practices involved in data science?
Some of the best practices that I can think of are, first is understanding the business case. I talked about that, understanding what you're trying to solve. Having alignment with the line of business is an important element from a best practice standpoint, for data science. The second thing is spending enough time understanding the data. That's, I would say, is the most important element. If you do not have access, if you do not have a clear understanding of the data, you will not have good outcome on the results of your analysis. Then the third one is establishing the right workflow, making sure that you have done enough analysis, in terms of collecting the data, analyzing the data, uh, modeling the data, um, then deploying those models into production, revisiting the models, making sure that all of the best practices, in terms of the the data science life cycle are followed correctly. In fact, IBM came up with a term, called as AI ladder. And these are the steps. These are some of the best practices that you need to do. You need to take in the data science project. One is collection of the data, organizing the data, analyzing the data, and then infusing the data. For data science projects. So I would say establishing that right workflow is super important. And then finally implementing the tools uh, to to mitigate bias, maximize fairness. So those are some of the important elements that you need to consider as best practices in any data science project.
Thank you, Sampada ma'am. We have reached the end of our session, and it was truly a marvelous one. And I thank for aiding to students' curiosities with your expertise. Thank you, ma'am. There is a one important announcement for the students. It is necessary for all the students to fill the feedback form. The link of the feedback form is given in the description box, and e-certificates will be generated within the 10 days from this program. So please fill the feedback form. Now I invite Miss Vaibhavi to extend the vote of thanks.
Honorable dignitaries, distinguished guests, and all dear participants. On behalf of Satish Pradhan Dnyanasadhana College, its entire fraternity and the organizing committee, I feel immense pleasure to take this opportunity to propose vote of thanks to our eminent guest, Ms. Sampita Vasarkar ma'am, who spared the time from her busy schedule to grace this webinar with an extremely relevant address on driving force behind the demand for data science. I take this opportunity to specially express my deep regards and gratitude towards Sri Satish Pradhan sir, Treasurer Satish Seth sir, Secretary Kamlesh Pradhan sir, Mansi Pradhan ma'am, our Honorable Principal Dr. C.D. Marathi, Head of Department Vaishali Jadhav ma'am, and an extended thanks to our technical team, which was supervised by Abhinandan sir, Rajmohan sir, Tripti ma'am, and our dear friend Amardeep Singh. My deep sense of appreciation also goes to our all dear participants who chose to be live with us and attended this webinar with great enthusiasm. My sincere gratitude also goes to our organizing committee for taking topics that really matter in today's age and time. Once again, I thank you all for being with us. Have a wonderful day ahead. Thank you.